Hey guys, so today we're gonna go over this question. If you didn't watch the first part, this was the original question. We have this function, and here we show using the inversion method how to sample from it. But here we are using the acceptance-rejection method, and we know how to sample from this g of x. Okay, so now we show how to use the acceptance-rejection method to sample the full distribution of f of x using the following proposal distribution g of x. What is the efficiency of the sampling? And we're going to show how we're going to use the acceptance-rejection method. So g of x looks like this. I just rewrote it, and this is f of x just for convenience. Now we will create h of x, which will be the c, which is the maximum of f of x divided by g of x. So I wrote the function, and now our goal is to find the maximum value. Okay, so we're trying to find the maximum, so I will try to find the maximum in this area and then the maximum here. So this is supposed to be really easy for you guys. So q of x will be this area, and then I try to find where the derivative is 0, and then I saw that when I do 1 minus x squared equals 0, I will get x squared equal 1, meaning x will be plus minus 1. But I'm only interested in between 0 to 1, so I will just check 0 and 1, because here I saw there is a potential maximum. So I just check both points, and I get here 4 divided by 3, which is around 1.33, and here I get 0. Okay, so this is a constant, and then I set another function p of x, which will be 3 divided by 2 times x e to the power of s squared minus x to the power of 3, and then derivate. Okay, and then I'm trying to find the maximum value. By the way, it's supposed to be to the power of 3 here, and now I'm trying to find, and I'm getting that the maximum value will be when x is equal to 1, then I will get 1.5. So this is the c value we will use. Okay, and now when we find out c, we will sample y from g of x and from u, which is 0 to 1, yeah, uniformly, and except if we gonna have this value, that u will be less than equal to f of y divided by c times g of y. So now we'll set k of x, that will be f of x divided by c times g of x, just for convenience, and I just wrote it. So I just rewrote it here. So the value of k of x, just for you guys, so it's easier for you to understand, I just wrote this ratio, so it's easier for you to actually put the values. And now we're going to use this algorithm. We sample y from g of x and u from 0 to 1. If we get a value of y which is between 0 to 1, okay, and u is less than 16 divided by 9, this area, times y divided by y squared plus 1, then we accept y. Else, if y is bigger than 1, and this condition, so this go here, y times e to the power of y squared minus y to the power of 3, then we accept y. Else, we call this function again one more time until we accept it. With y accepted, set x to y, then the value we use for of f will be this y, which is, now we called it x just for formality. And they ask us also what is the, how it's called, what is the efficiency? So the efficiency, it's pretty easy to see. That will be 1 divided by 1.5, 1 divided by c, and meaning will be 66 point something percent. Okay, so it's 2 divided by 3, 2/3. Hope you like this video, these videos, guys, and until next time, I'm out. Please subscribe.